Good morning, students. Once again, welcome to my GATE class. And today, I will going to solve some more problems for you. Once again, it is from 2019 paper, 2019 electrical paper. In the circuit shown, the switch is closed at t equals 0. The value of theta in degrees, which will give the maximum value of DC offset of the current at the time of switching. Now, once again, I will repeat. In the circuit shown, the switch is closed at t equals 0. The value of theta in degrees, which will give maximum value of DC offset of the current at the time of switching. Now first you identify the problem. This is from AC transients. AC transients. Transients means a kind of disturbance. And once the transients dies, then only system can enter steady state. Therefore, before any system entering the steady state, it has to pass through what is known as transients. And the students study transients under two headings: DC transients and AC transients. DC transients means transients observed in DC circuits. AC transients means transients observed in AC circuits. So if transients has to be observed, then the network must have either inductor or capacitor. Inductor, capacitor are responsible for transients. And in gate, normally we see DC transient problems, but in this year, rarely a question had come on AC transients. So students has to very well remember the expression. First of all, I will explain few points for you. Then I will solve this problem. First, the switch is closed at t equals 0. T equal to 0 means at any instant. For example, if I am closing switch at 8 p.m., then 8 p.m. will be starting. That is t equal to 0. Now, the value of theta, for what value of theta, the current will have a maximum value, DC offset value at the time of switching. First, I will explain few points for you. First, let us make calculations. So, what is this 377? 377 is angular velocity omega. Omega 377 radians per second. Then, what is impedance of the circuit? Impedance of the circuit is square root of R square plus XL square. That is square root of resistance 3.77 square plus XL. XL means L omega equals 0.01 into 377. That is also 3.77. 3.77 square equal to 3.77 root 2 ohms. Now first you must understand what is this theta. 377t plus theta. That means theta. If this is the sine waveform, 377 sine 150 sine 377t plus theta. So this is sine waveform, magnitude 150 plotted against time. This is 150, this is minus 150. 377 is omega. Theta. What is this theta called? Theta is what is called as phase. Phase means it can be here. For example, if theta is here, phase is here, then it is 0. Theta means the phase measured from this vertical line. For example, theta 90 degree means here, theta 90 degrees, theta 45 degrees here, theta 180 degrees, theta 270, theta 360. Okay, this is theta phase, because the switch may be closed here. When see, this is continuously changing, this voltage is continuously changing, so you are going to close the switch here while this voltage is passing through here, or you may close the switch arbitrarily when it is passing through maximum value. So that is called, that is going to have influence on the transient response. So this theta is going to have influence on the transient response. So that is why in this problem, for what value of theta, the DC offset will have maximum value. First, I will write the solution. And students must remember the expression. See, in the gate examination, you are not supposed to derive this. There is no time at all. Now I will write the expression solution. I of t is equal to Em by z sin omega t plus theta minus lambda minus Em by z sin Em by z sin lambda minus theta, sin lambda minus theta, lambda minus theta, theta minus lambda, e power minus r by L t. So this is the total solution. Now this solution is of two parts. This part. This part is what is called as steady state response. Steady state. When this part becomes zero, then system enters into steady state. Steady state solution. Whereas this part is what is called as transient part. Transient part of the solution. And you must observe, here there is T. That means it is periodic in nature. This part is periodic in nature. It continuously varies with the time and phase. Whereas this one is a constant term, because theta is a constant, lambda is a constant, Em is a constant, impedance is a constant, R is a constant, L is a constant, and L is a constant. Only T is variable. So no doubt this part is variable. It is varying. But in the problem it is mentioned that T is 0. Therefore T is 0 means this becomes 1. Now the question is for what value of theta this portion, transient part, is maximum. That is called as offset. DC offset means this portion will have a maximum value during starting. So you have to find that value of theta. Now to find Em is a constant, Z is a constant, forget about e power minus r by Lt, because it has become 1, because at t equal to 0. Now I will take sin theta minus lambda. Sin theta minus lambda. Sin theta minus lambda. What is lambda? Lambda is tan inverse XL by R. Lambda is tan inverse XL by R. That is tan inverse 377 by 377. That is tan inverse 1. Tan inverse 1 means pi by 4 radians are 45 degrees. Pi by 4 are 45 degrees. Pi by 4 are 45 degrees. Now, you have to find out for what value of theta the DC offset value will have a maximum value. That is, sine function becomes maximum only when sine of theta minus lambda or sine will have, what is the maximum value for a sine function? Sine function maximum value is 1. So when theta minus lambda becomes equal to pi by 2, maximum value occurs. Pi by 2 means 90 degrees. Pi by 2 means 90 degrees. Now in this problem, lambda is 45 degrees. Theta minus 45 degrees. Theta minus 45 degrees is equal to 90 degrees. Is equal to 90 degrees. And one thing, a slight correction. Please make a slight correction. This is lambda minus theta. This is lambda minus theta. Lambda minus theta. Here also lambda minus theta. Lambda minus theta. Slight correction. Lambda minus theta. So lambda minus theta becomes 90 degrees. Then the offset will have maximum value. Now what is this theta? Minus theta. Minus theta is equal to 90 degrees minus lambda. In this problem, lambda is 45 degrees. Therefore minus theta is equal to 90 minus 45. That is 45 degrees, or theta is equal to minus 45 degrees. 45 degrees. When theta becomes equal to minus 45 degrees or pi by 4 radians, minus pi by 4 radians, then the offset will have maximum value at t equal to 0. And that ends the problem. So in this problem, I hope that students have noticed the slight correction. So minus em by z sine lambda minus theta e power minus r by l t, and theta, answer is theta is equal to minus 45 degrees, and that ends the problem.